welcome to the next chapter in Year 11 Methods, all about trigonometry. So first we're going to start off with a bit of a review of trigonometry, what you should already know from Year 10. So basically let's start with a right-angled triangle. So here's a poorly drawn right-angled triangle. There's its right angle down there. And we can label the different sides. Oh, let's put in an angle. So we'll put this angle in. Now, let's label our different sides. Let's say this side that's next to the angle, we'll call that the adjacent side. Adjacent being just a fancy word that means next to. This side over here, let's call it the opposite side because it's opposite the angle, so we'll call it the opposite side. Opposite. And this one, only if it's a right angled triangle, it's the longest side. It's also, I like to think of this little right angle as kind of a bit of an arrow in itself. So the thing that's opposite the right angle we call the hypotenuse. Hypotenuse. Now because these words are long and annoying, we're just going to say this hypotenuse represented by H, opposite side O, and adjacent side by A. Okay, so our trigonometric ratios are basically these things. People notice that no matter what size this triangle is, suppose the triangle was cut a bit, so it became this big. So here's our new triangle. People realize that even if this happened, the ratio of the opposite side compared to the adjacent side, or the hypotenuse compared to the adjacent, or hypotenuse compared to opposite, those ratios stayed the same. And so that's why they're called trigonometric ratios. And there are three of them, and you've probably all seen and hopefully already understand them. Let's just get rid of some of those things. Okay, so first off, some people like to remember the SOHCAHTOA, so just CAHTOA. Some people like to remember that just to refresh your minds. That's a thing. Personally, I just remember what it actually is. So firstly, there's sine. So sine's actually, the word is sine. It's actually, if you write it out in full, it's that, sine. But mathematicians don't like to use more than 3 letters, preferably less if we can get away with it. So anyway, the sine of this angle over here, and this is a theta, so this is theta, a Greek letter always used for angles, one of the ones used for angles. Sine of theta is the opposite side divided by the hypotenuse. And that's why it's so. Sine is opposite divided by hypotenuse. Next one, we write it as cos, but really it's cosine. Cosine is what it really is. So cos of the angle, cosine of the angle is the adjacent side divided by the hypotenuse. That's why it's CAH. Cos is adjacent divided by hypotenuse. And for TOA, it is going to be tan. We write tan. Really what that means is tangent. Tangent. And tangent is opposite over adjacent. So there we go. 3 sides, 3 different possibilities of which ones we're talking about. They're all represented there by sine, cos, and tan. So, often our questions will look a little bit like this in nature. Okay, there'll be some sort of angle and there'll be 2 sides. And that's basically all there'll be to it. So, I should probably mention, with right-angled triangles, there's these 3 trigonometric ratios we can use. The other thing we've sort of got up our silky sleeves is, of course, Pythagoras. Pythagoras. And Pythagoras' theorem is often represented like this: a squared equals b squared plus c squared. But now we can be a bit more clever about it with our new labels and say that the hypotenuse squared equals the opposite side squared plus the adjacent side squared. So I just wanted to flag Pythagoras' theorem, comes in handy when we're talking about right-angled triangles, same as trigonometry. Anyhow, here is a typical sort of question. We might be given 30 degrees, We might be told this side length is 5, whatever units you want to use, centimeters maybe. And we might be told one other side. So let's say this side down here is x. It's an unknown. So we're given two things and we're asked to find a third thing. So here's going to be our method. First we need to figure out what information we have. So we're going to list our information. List our info. So here we've got an angle. It's 30 degrees. We know the hypotenuse. The hypotenuse is 5 centimeters. And we're looking for our adjacent side. So we're just going to say the adjacent side is x. Okay, so step 1, list our info. Step 2 is find the right ratio to use. Find the right ratio to use. So in this case, we look for the one that's got the angle, the hypotenuse, and the adjacent side. And we hopefully will come across the cosine one. It's got the angle, the adjacent, and the hypotenuse, the same three things we're looking for. So I'm going to use the cosine of the angle equals the adjacent divided by hypotenuse. Now I'm just going to put my information into that ratio. So I'm now going to say cosine of 30 equals the adjacent side is x divided by our hypotenuse is 5. So now we're up to step 3, which is solve by rearranging. Solve that thing by rearranging it. So we're trying to get x by itself. So for this case, we're going to multiply both sides by 5, so that this 5 disappears from this side. So on this side, we've only got x, and we multiply both sides by 5, giving us 5 cosine 30. Now all we have to do is put 5 cosine 30 into our calculator. Let me just do that. So here we go. We can say 5 cosine, so trigonometry is what we're doing. Cosine and 30. And it says there's no exact answer. Let's get an approximate one. Here we go, 0.771257. Now, at this point, what I want to say is there are two different measurements for angles that are common. So for instance, here we've got 5 centimeters. Imagine if we hadn't written centimeters, instead we had written, say, inches, our answer would obviously be a different length. And it's similar with angles. We could use degrees, but there's another one called radians, which you're going to learn about very shortly. So we've got to make sure our calculator's in degrees, because I don't think it is at the moment. So to make sure it's in degrees, we've got to go to our settings. So number 5 for our settings. We're looking for our probably handheld settings. And let's see, what have we got? Nope, wrong. Must be settings, document settings. Here we go, it says our angles are measured in radians. We don't want that, we want them in degrees. So once they're in degrees, okay. So let's try again. Get a new calculator page and try that again. So we're doing, let's just remind ourselves, 5 cosine 30. All right. 5 times cosine 30. There we go. So here's an exact form with the surd in it. If we want the approximate answer, we've got 4.33, so on and so forth. So our exact answer is x equals 4.33, blah, blah, blah. Okay, now very last step, step 4, does it make sense? It make sense. Okay, so let's have a look. Well, x is the adjacent side here, and it's obviously going to be shorter than the hypotenuse, but with an angle of 30, if we had drawn this a bit more accurately, it might look a bit more like this, 5x, because that's a bit closer to 30 degrees now. So if we're looking at it, it's going to be less than 5, and probably not too much less. So our answer is 4.33, and yes, that's definitely less than 5, and it's not much less, so yes. It does make sense, and so let's, does it make sense? Yes. Also, we need to think units. So our final answer will be x equals 4.33 3, 3, and unit with centimeters. Unit of length, centimeters. Excellent. So there's a very long-winded explanation. So follow this pattern. Listing our info, finding the right ratio to use, solve by rearranging. Doesn't make sense. Let me write those again, and we'll do another couple of examples. So, steps. Let me just write these real quick. So, list info. 1, 2, choose ratio, or you can think of this as the equation to use. Choose the ratio or equation. 3, solve by rearrangement. Solve by rearranging. And 4 doesn't make sense. Make sense. And also like units. Okay, excellent. So let's do another example using these 4 steps. Okay, so here's our next example. We've got this triangle here. Okay, so let's start by first listing our information that we've got. Well, we've got an angle which is 45 degrees. We've got an opposite side. That's our opposite side. Here's our right angle, by the way. So this opposite side is opposite because it's opposite the angle. So we know our opposite side is 13 meters. And here we're looking for the adjacent side. Adjacent side is x. Okay, so now we've got to choose the right ratio. So what has the angle, opposite, and adjacent in it? Hopefully you all know 10. 10 of the angle is opposite over adjacent. Put all my information in now. 10 of 45 degrees equals 13 over x. Okay, now I've got to rearrange. So first I'm going to multiply by x to both sides. Both sides by x gives me x tan 45 degrees equals 13. Now x is still not by itself, so I'm going to divide both sides by tan 45. Divide both sides by tan. You don't need to write these little bits in there just to help you follow what's going on. So now dividing by 10, I get 13 over tan 45 degrees. Okay, and now we're up to sort of the calculated part, if you like, unless you remember tan 45 off by heart. So calculated part, let's get that out. Let's remind ourselves what it is. 13 divided by 10, 45. That's interesting. There we go. So tan 45 is 1, as it turns out. We'll learn about that later. So our answer is 13. Now, interesting. So it turns out here that x equals 13. Now, let's put our units in. So it's going to be in meters. Now, part 4, does it make sense? Does it make sense that this is 13, the exact same as this? Well, it's roughly drawn pretty close to right. 45 here is half of 90, and so yes, it does make sense that that is in fact an equilateral triangle. This length and that length is the same. So yes, it does make sense. So there we go, that's our answer, x equals 13. Okay, one more example. Okay, so let's take a look. I'll try and draw this triangle a bit stupidly to make it a bit more confusing. let's see, what have we not done yet? Okay, so here's our right angle. The thing we don't know here is actually the angle, and we've got 12 and 13. Let's just make those millimeters for fun. Millimeters there. Okay, so first we want to list our information. So step one, listing our information. Well, we don't know our angle. Angle's x. Let's give it in degrees. We've got our, here this is the opposite side, it's opposite our angle. So our opposite side is 12 millimeters. And here we know our, that's the hypotenuse because it's opposite this side. It's also the longest side. So hypotenuse is 13 millimeters. Hypotenuse. Okay, so now we've got to choose one of the equations that contains this information. And we've got opposite and hypotenuse, so it's going to be sine. Now putting in the information, it's got sine of x equals 12 over 13. Okay, so now we're up to stage 3. We need to solve it by rearranging it. Now the thing that undoes sine is the inverse sine. So this is sine to the -1 undoes sine. And that's the same as if, say, you can also have like cos, -1 undoes cosine, and tan to -1 undoes tan. Okay, so in other words, they're the things that if you want to find the angle. So here I'm going to do inverse sine to both sides. Look what happens. Sine inverse of sine of x equals inverse sine of 12 over 13. Okay, so I've done the inverse sine to both sides. Now, inverse sine undoes sine. So the inverse sine undoes that sine, and on this side we're left with just x. And on this side we've got inverse sine of 12 on 13. So now this is where we can plug this into a calculator. Let us do that. So here in trig, we're looking for inverse sine. There it is. And we're doing a fraction. Get out my fraction thing. 12 on 13. And sorry, I want the exact answer of 60. The approximate answer is 67.4. So 67.4 x equals 67.4 ... and that's in degrees. Now last stage, does it make sense? Well, let's have a look at it. Yeah, it's definitely going to be a lot bigger than this other angle here. So yep, that makes a fair bit of sense. So yeah, that makes sense. Okay, and that's it. Those are basically the only 3 types of questions you're going to get. So one of them is going to be where you don't know the angle. One of them is going to be when you don't know whatever comes on top of this division. One's going to be when you don't know whatever's on the bottom of that divide sign. So those are the 3 sort of options. I guess you could make a case for there being a third option, I suppose. Let's suppose this is the question. Here, well, let's say this is x, this is, I don't know, 8, and this can be 6. If that's your question, note we can list our information. You can say hypotenuse is 8. Now, we don't know which one's the opposite and which one's the adjacent, so it doesn't really matter. So you could put your angle in somewhere. You can choose if you want to. So this one I chose. It really doesn't matter which one you chose. So this means this is the adjacent side now, and the opposite side is x. So here the quickest way is actually to use Pythagoras. And remembering that the hypotenuse squared is opposite squared plus adjacent squared. So putting our information into that, 8 squared equals x squared plus 6 squared. So that taking away 6 squared, 8 squared minus 6 squared equals x squared. So x is now the square root of 8 squared minus 6 squared. X equals square root of 64 minus 36. X equals root equals the square root of 28. And that's an exact answer, so that will do. So that's perfectly fine. The other option is to first find your angle. Remember, it doesn't matter which one you chose. So if I wanted to, I could have said angle equals like question mark. So let's just use theta for that. And then you can say, well, we know these two, so this particular angle is going to be cosine equals 6 on 8. And then you can find this angle if you want to. So angle will turn out to be, inverse cosine 6 on 8. That'll be your angle. Then after that you can find this one here. You might want to use sine if you want to. So by the way, ignore this if it's not making sense to you. You can then use sine to find this one. Sine of our angle is this stuff. So let me just write this down. Sine of the angle is x over 8. So now our angle is going to be all this stuff. So let me rearrange this. 8 sine of the angle equals x, the thing we're looking for. So x equals 8 sine. Now our angle is this. And then you can put all that into the calculator if you want to. Now my recommendation is just to use Pythagoras, but I want to show you that you can use trigonometry twice. Here's one time, here's 2 times. So using like the trigonometric process 2 times. It is more difficult though because you have to choose your angle, and it can be a bit daunting for some people to choose which one they're going to use, even though it doesn't actually matter. Okay, so there you go. That's the end of revising trigonometry. Best of luck to see you in class.